If you've watched some of the other segments of our show, you know that I am an advocate of sticking to the original set of materials and curriculum, and especially philosophy used by Dr. Maria Montessori herself. One of the places that I do vary from that is in the math area. Now, I still believe that if you are going to use a material other than what she used and proved was effective in her classrooms, you need to have a really good reason for doing that. I feel very much that the philosophy ideas are not things that should be varied from. That approach to children, that way of respecting their concentrated work, has been proven over the years in many classrooms throughout the world. However, there are things that I believe we can test to decide whether or not there are ways to improve the Montessori approach to educating a child. In this segment, I want to talk a little bit about some math materials that I call second-generation math materials. And the reason that I call them that is that they were designed by people who did very high quality Montessori training, as well as other research, other work in the area of math and math instruction, and then took the ideas that they learned from working with the Montessori math materials and from their other experiences and created new materials. In the case of Jerry Mortensen, a lot of the materials that he created look very similar to some of the ones in the original set from Dr. Montessori. If you look at his bars, they are not made of beads, but they have the same quantities represented, only with a very clean rectangular or square shape or cube prism shape rather than a bead. And there's some advantages to that. He has 100 squares, very much like the bead squares, but again with some precision added to it. In the case of Dr. Joan Cotter, she does use beads, but rather than using beads in the form of bars and squares and individual beads, she uses them on a frame in the way of an abacus. So rather than having a 1 bar and a 2 bar, etc., all the way up to 10, you have a set of 10 beads that are on one wire of the abacus. And I believe that these materials give some advantages that the original set lack. In the case of in the case of Jerry Mortensen's materials, that precision, that ability to see exactly when you have a bar that has 3 units and a bar that has 4 units sitting next to a 7 bar, at a glance you can instantly see that a 3 and a 4 make a 7. This is not always the case with beads because of their round nature and the variation that comes when they're strung on the wires. In the case of Joan Cotter's materials, I believe one of her great contributions to Montessori is the idea that we want the children to see quantities rather than to count quantities. And her materials do facilitate that. I know from my own evolution in my math thinking that if you are going to become adept at doing math in your head, you tend to see quantities. You're not counting things out one by one. It's just not fast or efficient. So from my perspective, what I've seen over the years is that both Dr. Montessori's math materials and these second generation math materials give any child, any adult, a chance to think about math in the way that people who are naturally good at it do in their heads, to make the pictures that they make just perhaps as the way that they're wired, to make those pictures by learning to make them by using the materials. Joan Cotter talks about one of the children, when asked how they did a problem without using the abacus or any concrete materials, said, "I see the abacus in my head." And that is what we want. We want the children to move through a progression, a passage to abstraction, where they are accurately doing math with the materials and then internalizing those math principles. And rather than just internalizing operations, a series of steps, people who are really good at math and who are able to use math in a variety of ways have visual representations, and this is the real promise of these materials. Now, what I'm going to suggest is that before you look at the segments from what I was able to film at a American Montessori Society conference, that you think about your own experience, if you have some, with the Montessori math materials, and where the children seem to use them seamlessly, and where maybe you've noticed some difficulties with that. I believe that in the case of the kinds of materials that I'm discussing, it would be very appropriate and very worthwhile to do some actual research, to have a classroom with a well-prepared Montessori educator using only the traditional Montessori math materials, have another classroom matched as much as possible, the way that good academic research is done, with the second generation materials, and see what kinds of different things we're learning about that. I believe that's very appropriate. Whereas we would not want to take away some of the things we know have worked in Dr. Montessori's method to test how to better teach math in this way. I think is very valid research and would not be doing any harm. It would be allowing us to see what experiences children have and what is most effective. Now, in addition to looking to see just how we can improve what the original set of materials did and how the children work with them, we also need to look at whether there are gaps. One of the things that is happening now is that we do have the Common Core math standards that many schools need to work within, and even Montessori schools that are not required to do that. Because these standards are becoming so common and so pervasive, it's really important that especially any Montessori elementary educators have a sense of what they are, what kinds of competencies are measured by those standards, so that they can make sure that they are covering those bases in their classroom, maybe indirectly, but definitely they need to have a sense of that. And this is one of the places where some of the materials that I have discovered at conferences and then gone on to recommend to the director at a school where I worked and use them with my upper elementary students, I think are a real valid addition, and again, worthy of being called second generation Montessori math materials. You can do negative numbers work, you can do number line work with the Montessori beads, but they are not a really elegant material for that, just as they're not as precise as the Mortensen bars. So some of the work that I'm going to share with you from these clips that I did are how we can bring those kinds of concepts into our classroom in a concrete way with materials that are very congruent with the original ways that Dr. Montessori presented math. Another concept set is our working with data. This is one of the areas that I really encourage Montessori educators to look at in the Common Core standards. This is not an area that has always been very well presented in Montessori classrooms, but presenting graphs, presenting how to work with probability, how to work with comparing different data sets and coming to logical conclusions with those, as well as collecting and recording and analyzing data. These are things that we need to be doing in our Montessori classrooms. At a very basic way, even in the 3 to 6 classroom, in the primary classroom, but definitely in the elementary classrooms, lower elementary and upper elementary, that needs to be done. So I encourage you to think back on your own experiences with the Montessori math materials. Where do you believe improvements could be made? Where have you seen that things work beautifully, and where perhaps do you think there is room for improvement? I also encourage you to read what other Montessorians have said, what their experience is with these different materials, especially Jerry Mortensen's materials and Joan Cotter's AL Abacus, which I have found to be very effective and a favorite with the children.
Children 5 months old can already add and subtract. up to 3, and they are not counted. We should not say to a young child that this is 1, 2, 3. It's not. It's 3. And most children know the names of the quantities as far as their age. So a 4-year-old knows this, and a 5-year-old knows this. And then we have a little song that teaches them past 5, because most children don't know this. Yellow is the sun, 6 is 5 and 1. Why is the sky so blue? 7 is 5 and 2. Salty is the sea, 8 is 5 and 3. Hear the thunder roar, 9 is 5 and 4. And ducks will swim and dive, 10 is 5 and 5. And they love that. And we can go on to the abacus. Notice it's grouped in 5s. I got the idea from doing this for Montessori's black and white read stairs. And always when you teach, you start from the known to the unknown. So can you show me, say 3, and enter 3. Now sometimes children will start by saying 1, 2, 3, and I'll say, okay. Now can you do without counting? There's my 3. I actually did this with a girl, actually in Holland, the day before she turned 5 years old. And of course she had learned to count everything. And I don't speak Dutch, so I was allowed to speak to her in English. She's very happy to work with me. I timed how long it took her, and this is exactly what I did with her. When you show me 2, enter 2, and she wanted to count. And then I showed her 3, and then 5, and then I did 4, and so on. So many times she'd go back and counting and say, can you do without counting? In 20 minutes, she could enter any quantity from 1 to 10 without counting. All along her a child who had spent years. Now let's see some of the neat things we can do with this. Let's add 4 plus 3. There's 4. Here are 3 more. I got my answer instantly. No. And the best part is I can see it in my head. See 4 in your head, see 3 in your head, and then turn into 5 and 2. And that's exactly what the Japanese child is taught to do early in 1st grade. Japanese children, once they start school, are taught not to count. They never count to find 6 plus 7. As long as I'm talking about 6 plus 7, let me show you how you can remember that one. There is 6, here is 7. Notice all the blues make a 10, so we have 10 and 3. And you can see that in your head. And even children with learning disabilities, or maybe especially children with learning disabilities, report they can see that in their heads. And remember, a child is considered to know a fact if they can do it in 2 seconds. 2 seconds is plenty long to bring up this picture, read it, and recite the answer. Now let's look at multiplication. 6 taken 3 times, Montessori's terms. Look how easy that is. See the 15 and 3 more? There it is. Well, telling time. Here's a penny, a nickel. A nickel is all one color. A dime is one row. And then those quarters. Whoever designed American money, we're not thinking of children. But we've got the quarters. There's 1, 2, 3, 4. There are 4 quarters. Let's go back to another multiplication problem. 7 times 7. That's my favorite one. See the 7 times 7? Now, how much is this? Well, you see inside here is 25. See the 10 here? That's 35. Another 10, 45. And the last 4, 45. And you can go through that in your mind. Less than 2 seconds. 25, 35, 45. There it is. Ever forget it? Go back and do it. Now, let's turn the abacus over. Now, I came up with this because I was so frustrated with Montessori's lead frame. Because you cannot enter 2 addends, both numbers to be added, without trading in the middle of the second one. But here you can do it. Look. Here's 8. Here's 6. You can see it's 10-4 or 14. But we don't like 14 ones, so we have to do a trade. And I like to use 2 hands, but we'll just do it with 1 hand here. 10 ones is 110. See the answer? Now, actually, the way the children like to do this, let me show you this. You get ready, get set, trade! That's a lot of fun when you're 5 or 6 years old. Now, I first did this with my kindergarten-age children, and we did 4-digit numbers, not just 2-digit numbers. And they did between 6 and 10 of them. And then one morning I said, do you think you could do this without the abacus? I challenged them. And they all could. And they were so excited. They knew what they were doing. Except one girl. And I found out later why she wasn't excited. Her mother had taught her the night before. So she was deprived of the children.
I'm Ruth Gunasinghe, and I invented the number line manipulative. The number line manipulative has many uses, and students are able to visualize integer operations, absolute value inequalities and equations geometrically. So I'd like to demonstrate some of the uses of the number line. The number line comes with two parts. This is the number line, and it's numbered from 0 to 20 and 0 to negative 20. Of course, the number line is infinite, but this number line just represents some of the integers. Students should eventually use paper and pencil for bigger numbers. The second part of the number line are these rods, and these rods are centimeter long, and they have a number at the end of it which tells you how long each rod is. The white part, I call it the head, and the rest of it is the tail. And when we perform integer operations, we add, like adding vectors, head to tail. We never add head to head or tail to tail. So we have to place the rods on the number line this way, head to tail. So let's do a simple operation. And let me get a paper and pencil and write it down. I want to add 8 and 3. I would pick up the 8 rod and the 3 rod. We have to start by placing it at 0, and because we're talking about positive 8 and positive 3, we point the rods in the positive direction. So that's my 8, and then I add 3, and so we have 11. Alright, so let's do one with subtraction. Okay, so now subtraction is defined as adding the opposite of the number being subtracted. So let's rewrite that. 8. It's always adding the opposite of the number being subtracted. So the number being subtracted is 4. And the opposite of 4 is negative. This means we can point the rod in the negative direction. So we have positive 8. Positive 8, so let's start with positive 8. And then we're going to add negative 4. So I'm going to place this, and remember, head to tail. So here's how I'm going to place my tail and my head. And what do you know? The answer is 4. It's the distance from 0. Well, what about something that's a little bit more complicated? So let's say negative 10, take away 6. Right? Again, we would start with negative 10, and we're going to add the opposite of the number being subtracted. So that would be 6. So pick up the 10 rod, and then the 6 rod. So because it's negative 10, point it in the negative direction. So we have a negative direction, and we have a size of 10, and then we're going to add a negative 6 to it. Now we can add it here or in the other column, and we end up with negative 16. Hey there, I'd like to show you a graph board, and this piece of material can be used for kindergartners or preschool. And the graph board has this board here with whiteout, so whiteboard, you can actually erase it. You can erase it and make it whatever you want. So today we're going to take a poll of your favorite ice cream. And so when a student comes in, you can ask them their favorite ice cream, write it down there, and you can actually scale this to whatever you want. So when the kids come in, you can say, okay, pick up a cube and place it here. So if they like strawberry, they're going to place the green one. And if they like mango, they're going to place it there. And once we reach 10, you can replace it with the 10 rod. And basically take a poll. Now students can find these graphs in a newspaper. And I would advise teachers to connect the graph board with their social studies and science lessons for the day, and have students do a little research and find out the kinds of bugs that are in their garden at a certain time of year. So you can actually connect it and then make a board so that students can visualize their findings.
In this phonics segment, I'd like to address something that has been a pet peeve of mine. I believe that most words in the English language can be sounded out to a great degree. There are a group of words that are referred to variously as sight words, high frequency words, and in the Montessori environment sometimes as puzzle words. I've even seen secret words and other things associated with them. Now, those different terms can mean different things. A high frequency word is simply a word that occurs frequently in reading material. So the word "and" is a high frequency word. The word "though" is a high frequency word. Now, "and" is completely decodable. If a child is sounding out the word, if they know the short sound of A, they know the N sound of N and the D sound of D, the only sounds those letters have, they can sound that word out. "Though," on the other hand, has the tricky combination of a consonant digraph at the beginning of it, an OU sound that's one of 6 that combination of letters makes, and then some silent letters thrown in at the end. So those words are, in my mind, very, very different. I prefer to talk to children about words in a different way. If you have words that are high frequency that the child can sound out, it's certainly worthwhile to have exercises where they can review those words before they're working with readers. I call them keywords because they're the keys to the books. But I sort them out. I sort them out for the children on a card and help them see that the ones that are easy to sound out, you just sound them out. Then the ones that are trickier, words like "though," what I like to do is to point out to the children, sometimes actually visually on a card, where's the difficulty. One of the very first sounds that a child does need to sound out beyond the basic single letter sound combinations are the TH sounds, because they do occur so frequently in our language. So if you've got a little line under that to show the children that those two letters make a sound together, then perhaps if you've got strike through on the GH of those so that they recognize that those are silent letters, that can help a child sound those words out. And I'm going to suggest that there's no such thing as a sight word as an individual word or as a set word. Any word is a sight word if you can say it on sight. If you know the word elephant as soon as you see it, elephant is a sight word for you. If you have to sound it out, then it's not. Sight words are not a set of words. What we have in our language are words that are phonetically regular, words that are phonetically irregular. We have keywords, words that children do need extra practice with so that they do feel confident before they're attempting to read sentences in books. I like to call those keywords. But to say that there are a set of words, puzzle words, sight words, that you're supposed to memorize is ridiculous. Why should a child memorize a word when if they're learning the letter sound combinations anyway, they can use that content set, that understanding of this letter makes this sound. If they could use that, why would they try to memorize a picture of a word in their mind? That doesn't make any sense. So I'm going to suggest that the idea of sight words be reworked and the idea of puzzle words be thrown out of the Montessori environment entirely. If you have a keyword set in your classroom, if you have words that you're going to make sure that the children are very familiar with, that's a worthwhile piece of material on the shelf. To have a keyword set on the shelf that they practice, whether it's individual cards or with just one word on a card, or a card that has many of these frequent words, maybe the top 12, top 20 right there where they can even have that card with them when they're reading beginning phonetic readers. To my mind, this is a much more logical approach. The children are learning the sounds anyway. Why throw in something that they're supposed to have to memorize by sight? That doesn't make very much sense to me. So I'm going to suggest that you rethink the idea of sight words, puzzle words, and regroup so that you can help the children learn those high frequency words, learn the keys to books without giving them the idea that there are words that just have to be absorbed whole the way that they would recognize a picture of an elephant.